Hello, my name is Hadi Farhangi on basics of statistics, histogram, and distribution. The content of this video, first introduction, then histogram, and finally distributions. The first topic, introduction. A statistical variable is a variable that takes different values non-deterministically. A bar chart is a chart that displays observations on a horizontal axis and the value of each observation on a vertical axis. Histogram resembles a bar chart. However, the horizontal axis shows the ranges of values of a variable. The vertical axis shows frequencies. Formal definition: histogram is a frequency chart for a statistical variable. It shows the frequencies of observation for all ranges of variable. Frequency in a histogram is the number of observations in a given range. Note, the length of ranges is the same in all ranges. The height of a bin or a bar shows the frequency or the number of observations in each range. Here's the example of a histogram. We have 4 ranges. For every range, the height of the bin shows the frequency of the variable within that range. Next topic, histogram. How to create histogram? Either calculate the number of bins or decide on it, call it B, to find the length of ranges, or using this formula, R is equal to max minus mean divided by B. Max of variable, mean of variable, subtract them, divided by B, it is your range. Find all ranges with length R following the below pattern until the max of the variable is reached. Here's the pattern. First range, the lower bound is mean inclusive, the upper bound is mean plus R exclusive, and the length of course is R. The next range starts from the upper bound of previous range, mean plus R, and upper bound mean plus 2R. And you have to continue until your upper bound is reached. 4. Calculate frequencies. The number of times a variable is within that particular range. 5. The height of a bin or bar is related to the number of observations in that particular range. Example: the following data shows the number of customers entering a shop in the last 11 days. Draw a histogram for this data. Here's the data, 11 days. The number of customers for each day is recorded. Here's the answer. 1, let B equal to 4, which we have 4 bins. Calculate R as max of variable minus mean divided by B. Max is 350, mean is 190 divided by 4, which is 40. Calculate ranges. First range starts from mean as lower bound and upper bound mean plus R. Mean of the observation is 190, R is 40, so 190 and 190 plus 40, so it is from 190 to 230. Next range from 230 to 270. Next range 270 to 310. And finally 310 to 350. These are the 4 ranges that we have. Calculate frequencies for every range that we found in the step 3. Here's the frequency table. The first range is 190 to 230. We have 2 observations in the data. Next range 230 to 270, we have 1 observation. Next 230 to 310, we have 3 observations. Then 310 to 350, we have 5 observations in the data above, in the table above, that is within that range. The lower bound is inclusive, the upper bound of each range is exclusive. Step 5, bar chart of this table will be the histogram. And here's how it looks like. All ranges are in the horizontal line. And as you can see, the first range, we have 2 observations. So the bar went up 2 points. Next range, we have 1 observation, so the bar went up 1 point. The next range, we have 3 observations. It went up 3 points. And the last range, 310 to 350, it has 5 observations. It went up 5 points. And that's how we create a histogram. Next topic, distribution. Distributions are built based on the concept of histogram. Particularly, they are defined for variables. If one increases the number of bins and connects the tip of the resulting histogram, a distribution will appear. Note that instead of frequency, in this case, one should use relative frequencies. Here's the case of a frequency table. If you connect the top of the bins, a histogram will appear. In distributions, the area below distribution is equal to 1. Some distributions are symmetric, some skewed to the right, and some skewed to the left. The tail of distribution shows its skewness. For example, if tail is on the right, it is skewed to the right. Here's a symmetric distribution. Here's a skewed to right distribution, and here's a skewed to the left distribution. Some famous distributions are Bernoulli, binomial, Poisson, normal, and t-distribution. In the next video, I will talk about those.